Today's lesson is going to be over 7.5, solving logarithmic equations. I don't really think that it's that bad of a lesson, but we are going to be using our properties. So if you don't remember those, you might want to get out the notes where we went over all the properties, but we will be going over them here. So step one is going to be to condense each logarithm, and we're going to do that by using our properties if it needs to be condensed. Not all of them will need to be. Then we're going to use the one-to-one property, which basically states that if we have two logs, they have the same base, they're set equal to each other, then that means that m equals n. Okay? And then step three, we have to solve for those extraneous solutions. So not all of our solutions are going to work. What's going to happen is if we substitute it back in and we get a negative log, then that is what's not going to work for us. Okay. Let's try number one. So number one, there's nothing to condense. We have the same, that log base 5. So we can just go ahead and set the 5x plus 9 and the 6x equal to each other. So we're going to have 5x plus 9 equals 6x. And when I solve this, I'm just going to get x equals 9 because I would subtract the 5x over and get x equals 9. And that is it. Now, I do want to check this solution. Just check it visually, plug it in. Make sure that if you plug it in, so 6 times 9 is not going to give me a negative number. And obviously, if I multiply 5 times 9 and add 9, I'm also not going to get a negative number. So as long as you don't get negative numbers when you substitute it back in, then you are good to go and it checks out. So I'm probably going to go down the left-hand column, and then I'll have you guys do the right-hand column for practice. So let's try number 3. Again, we have the same base, so we're good to just go ahead and set them equal to each other. So we have 6 minus 3w equals negative 2w. And I'm going to add my 3w over, which would give me 6 equals w. Now, if I visually just plug this in to check it, I'm getting 6 minus 3 times 6, which would be negative 12. So I'm getting a negative log, and logs cannot be negative. So this doesn't work. No solution. And if you even want to write to remind yourself, logs cannot be negative. Okay. All right, so that's what I mean by when you plug it back in, just make sure that you're getting those positive answers there. Okay, number 5. So we're going to use our property here that tells us that if we have this number out in front, this multiple out in front, remember that it can be moved back up as an exponent. So this would be log base 7 of 4 to the 3rd power equals log base 7 of 4a minus 8. I'm actually going to take 4 to the 3rd power, and when I do that, I get 64. So I can just set 64 equal to my 4a minus 8. Just using those properties. I'm going to add 8 over. I get 72 equals 4a and divide by 4, so a is 18. Check it, plug it in, make sure that it works. If you plug 18 in, 18 times 4 minus 8, you're not getting a negative number, so it works. And you can't even substitute it into the other side, so you are good there. Okay, number 7. Again, if we have a multiple out in front, we can move that back as an exponent. And this is going to be log base 6, 25 to the 1/2 equals log base 6, 23 minus 4w. Okay, 1/2 is the same as the square root, and the square root of 25 is 5. So this is just going to be 5 equals 23 minus 4w. I'm going to subtract my 23 over, which would give me negative 18 equals negative 4w. Divide by negative 4, and I get w equals 9/2. I'm just going to leave it as a fraction. If you want to write it as a decimal, that's fine too, 4.5. Visually plug that back in, make sure that it works. It does. So check, you are good to go. That is a solution. Okay, I'm going to do one more in this section, and then we're going to move on to the type 2. There's not really anything to condense here, but I am going to set these equal to each other. So I have m squared equals 18 minus 7m. Hopefully notice you have a quadratic here because of that m squared. So I am going to make sure I set it equal to 0. And you're probably going to hate this part, but this is going to require me to factor. Good news is it's easy factoring. What are two numbers that multiply to be negative 18, but add to be 7? That would be 9 and 2. So I have m plus 9 and m minus 2 set equal to 0. So I need my two solutions here, which would be m equals negative 9 and m equals positive 2. And both of these actually check out and work because negative 9 squared would be 81, 2 squared would be 4, and it works on the other side as well too, if you substitute them in. Okay, that is it. I want you to do 2, 4, 6, 8, 10 on that column, and we're going to move on to type 2, where is log equaling a number. So first thing that you're going to do is you're going to condense and isolate the logarithm if you need to. You're going to write the equation in exponential form. Since we don't have the same logs equal to each other, we do have to write it in exponential form to be able to solve it. And then we're going to solve and check for extraneous solutions. So number 11, there's nothing to condense here, so I'm just going to go ahead and write it in exponential form, which would be my base to the 6th power. So 2 to the 6th power equals x minus 4. 2 to the 6th power is 64, and then I'm going to solve this by adding 4 over, so x equals 68. Again, check it, make sure you're not getting a negative log. 68 minus 4 is 64, so you're good to go. This checks out. Okay, 13. We are going to have to condense here. Remember, if you have the same base, which this is log base 10, and you are adding, you can multiply those. So this is going to be log of 2x times x minus 5. You do want to make sure that you distribute here. So distribute your 2x to the x and to the minus 5. So this is going to be log, I'm going to have 2x squared minus 10x equals 2. Now that I have it condensed, I can go ahead and rewrite it in exponential form. This is a base 10, so base 10 to the 2nd power equals 2x squared minus 10x. 10 squared is 100. I'm just going to move everything over, so I have 2x squared minus 10x. I'm going to move the 100 over so that way I'm dealing with a positive 2 equals 0. Good news is here they are all even, so I can take a 2 out. And when I take a 2 out, I'm left with x squared minus 5x minus 50. And I can factor this easy enough. What are the two numbers that multiply to be negative 50 but add to be negative 5? That would be negative 10 and 5. So I have 2x minus 10, x plus 5 equals 0. I need to solve for both of these. So I'm going to, obviously the first one, 2 set equal to 0, there's no solution there. So this is x equals 10, and this is x equals negative 5. I again need to check both of these. If I substitute 10 in, I'm good. I'm not going to get anything negative there. But if I substitute negative 5 in, I'm going to get negative 10 and negative 10, which doesn't work. I can't have a negative log. So negative 5 doesn't work, but 10 does work. Okay, let's do one more together. Let's do 15. Well, actually, since 15 and 16, both of those are adding and we just went over an adding one, I'm going to do 14 because it's a subtracting one. And there's actually 2 steps here to condense this. So I'm going to do 14. So the first thing that I'm going to do is I'm going to take this 2, I'm going to make it an exponent, move that back. So I have log x squared minus log 4 equals 2. I'm subtracting. When you're subtracting and you have the same base, you divide. So this is going to be log x squared over 4 equals 2. I'm going to go ahead and rewrite this. So this is going to become 10 squared equals x squared over 4. 10 squared is 100 equals x squared over 4. I'm going to get rid of this divided by 4 by multiplying by 4 on both sides. So I have 400 equals x squared, and I'm going to subtract the 400 over. So x squared minus 400 equals 0. And I probably could have simplified those steps a little bit more. This is the difference of two perfect squares. You might be running out of room, I'm sorry. but this will be x plus 20, x minus 20. And I need to solve both of these. This is going to be set equal to 0. So I'm going to get negative 20, negative 20. Let me just erase that because I don't like the way that looks. X equals negative 20 and x equals positive 20. You want to check both of those. If I substitute negative 20 in, this is just an x right here. So that right away is going to give me a negative log. So negative 20 doesn't work, but positive 20 does work. So I have one solution, and it is just x equals 20.